Bismillahirrahmanirrahim. In this session, we will discuss the tangents and normals on the curve. So, suppose we have this curve, and here we have a tangent on this curve, where this line is intersecting or is touching the one point of this curve is a tangent, and on this tangent there is a perpendicular line is called a normal. So, in this exercise 12.5 of additional mathematics for IGCSE and O level mathematics, in this topic we will discuss the line of equation of this tangent and this normal to this curve. So in this section we will cover this is equation of tangent, and this is equation of normal, which is perpendicular to this tangent. So we have this exercise 12.5. The first problem, find the equation of the tangent to the curve at the given value of x. So we have to find a tangent, means dy by dx at x is equal to 0. Similarly for the other values. So we will solve one or two problems for this exercise. Question number 1. So let's move to question number 1. 12.5 equation of tangent. So y is equal to x4 minus 3 at x is equal to 1. So we take the dy by dx of this one. So this is 4x cube at x is equal to 1. The value of y is for this equation at x is equal to 1. The value of y is minus 2. So we have this is the point at x is equal to 1. The coordinates of this curve is 1 minus 2, and the slope for this coordinates 1 comma minus 2, we will place it, and we see that the tangent value is 4. So 4x cube means 1 at x is equal to 1, which is here. So we will have tangent value is equal to, or gradient is 4. So we'll place this value 4 here in this line equation, tangent equation. So placing this value 4 here, and x1 by 1, that is passing through the line is passing through this point. So we will place this 1 and minus 2 here. So this is minus 2 here, and 1 is here. So 1 is here, and y1 is minus 2 here. So this becomes y2 is equal to 4x minus 1, and y plus 2 is equal to 4x minus 4. Similarly, y is equal to 4x minus 6. By placing 2 here, it becomes negative. So 4x minus 6. This is the law equation of tangent. This is the equation of tangent that is the gradient, that is a tangent on this curve at this point. Similarly for this one, second, and let's move to problem number E. So this we have y is equal to x minus 3 to x minus 1 x square at x is equal to plus 2. So we will put this x value here to get the value of y. So x1 by 1 is 2 comma minus 9. The coordinates, if at this curve value, the value of y would be plus minus 9. So at x is equal to plus 2, the y is minus 9. So we have this point on the curve where the gradient is passing, the line is passing, line equation on this curve is passing, that is a tangent. So so dy by dx, we take out the dy by dx by taking uv. So this is u v dash So 2x minus 1, and then this 2 is here. This 2 is the internal part. So 2x minus 1 that is here, and then this 2x is 2. So this is v dash. From here to here, this is v dash, and this is u v dash, and then v this is v, and then u dash. So this becomes 2 to the 4x minus 3, and that's 2x minus 3, and this is 2x minus 1. So here we can take out 2x minus 1 as a common. So this is 4x minus 12, and this is 2x minus, so we can write it 6x minus 13. So this is the gradient value, and this we will place this x1 y1 which is 2 minus 9. So 2 minus 9, so we will place 2 minus 9 is so the value is x here, so we will place 2. So 2, so this becomes 4 minus 1 3, and this 6 12 minus 13 minus 1, so this is minus 1, this is plus 3, so answer is minus 3. The gradient is minus 3. So this is the gradient, and we have this gradient obtained, and this x1 y1 is already known from here, 2 comma minus 9. So we'll place this 2 and minus 9 here. So minus 9 is there, minus plus, this becomes this thing, minus 3x plus 6. So this is this 9 shifted here, so minus 3. So minus 3 may be taken common, so x plus, no, this may be written as this. So this is the required equation. Similarly, now left equation for the normal. So let's move to the problem number so this is number 2. So the equation of normal at the given value of x. So we need to find the normal, equation of the normal. So in the first part we have obtained the equation of tangent. Now we are solving the equation of normal. So this is problem number 2, the equation of normal. So this is the first problem, y is equal to x square plus 5x at x is equal to minus. So at x is equal to minus, then we put the value x to get the value of y. So this is x1 y1. We have obtained this y1 is equal to this one. X is, when x is equal to this, then y is equal to minus 1. So the x1 y1 are the 2 points from which the equation of normal is passing through. So we take the gradient dy by dx, that is the gradient of this curve, which is 2x plus 5, and by at this point this gradient is equals to 2x. In place of x we place the value, so it's plus 3. So the gradient of the normal, since this is the gradient of the tangent, so the normal would be reciprocal of. So the product of this will be the gradient of tangent and normal. The product of the two is equals to minus 1. That's why the gradient of the normal line is minus 1. So this is the gradient of the normal line, equation line. So okay, so the equation of normal have a gradient is minus 1 upon 3 due to this one. So y minus y1, so this y1 is available, x1 y1 is here, so we'll place it here and we will get this one. So this is the required equation. This is the equation. So let's move to part D. This is y is equal to 4 minus 2x square at x is equal to minus 2. So we'll place this x equal to minus 2 here and get the value. So we have x1 y1 in this one, and we take the gradient here. So this is 0, this is minus 2, and then minus 3 here. This 2 comes here, this becomes plus. So this is gradient is minus 1 over 2. So at this is the gradient of the tangent line of equation of tangent. So the gradient of the normal would be plus 2. So in place of normal, we will place this value, and this is x1 y1 is already now. So this will place this here accordingly, and get this 2x plus 4, and this is 1 upon 2, I think. No, it's 2. It's 2. 2x plus 4, this is 2x. So we should write it 2x. So this is 2x, correct it. This is 2x plus 4, this is plus 7. So this is 2x. So we need to correct it. Plus 4 plus 7. So this is 2x plus 7. Right? This one should be eliminated here. So this is at the numerator. So this is the correction is required here. So this is the value. And similarly for f part, we have this y is equal to x plus 2 divided by x minus 2 at x is equal to 6. At x is equal to 6, y is equal to 6 plus 2. So at x is equal to 6, we will place the value here. We get the value of y is this, and this is x1 and y1. So x1, y1 is available. So dy by dx is this. So once we get this dx by dx, we will place this value, and we get the gradient value. This is the gradient of the line of tangent. This is the tangent on the curve, and so the normal have a slope or gradient is 4. So this is for because of this, because the product of the two would be minus 1. So this is the gradient of the normal equation of normal. So in placing this to get the equation of normal. So this is x1 y1 is already known. So we place this value here. So this is 4x plus 1, y minus 2 is equal to this. So y is equal to 4x minus 22. So this is the required equation. Now let's move to problem 2 has been covered, and now find the equation of tangent and all this. Let's solve the problem number 4. The normal to the curve at the point 2, 5 intersect the y-axis at point P. Find the coordinates of P. The normal to the curve. So one of the equation that is normal to this curve at this point intersects the y-axis. This also intersects the y-axis at point P. Okay, normal to the curve, the equation line that pass through this point and intersect the y-axis. So intersect the y-axis means x is 0 at that point. So find the coordinate of P. Right. So let's move to question problem 4. This is the fourth problem. So y is equal to x3 minus 2x plus 1, and normal at 2, 5 intersect y-axis, that is x is equal to 0 at point P. This normal equation also crosses the y-axis where x is equal to 0 at point P. So this is m1 is equal to dy by dx is equal to this. So we take the gradient of this, which is at 2, 5 is 10. So the gradient of the equation of tangent is plus 10. So the normal gradient of normal would be minus 1. So in placing this normal gradient here, So this equation becomes 5 minus 5, y minus 5, and this x minus 2. This is 2. So on simplification, we get this y will be this. This normal line intersect the y-axis at point P. At point P, it intersect the y-axis. So at point P, this x is 0. So when x is 0, this y becomes 5 and 1 by 5. So the coordinate of point P is 0, 5, 1 by 5. So 26 upon 5. So this is the point which was the required. So let's solve exercise problem number 7. The tangent to the curve at the point P is parallel to the line. The tangent to the curve. The tangent to the curve. On this curve, there is a tangent line at point P. At some point P is parallel to the line. So this tangent will be the same gradient of this line, because this is parallel. So the gradient of this line would be the same of the gradient of this line. So find the equation of the tangent at P. So this is problem number 7. The tangent to the curve y is equal to 3x square minus 10x minus 8 at point P is parallel to the line this. So the gradient of the line, this line is m2, and the tangent to the line is parallel to the line. So this have the same gradient. So the gradient of the curve should be the same, this one. So this is the value of this gradient has obtained as 6x minus 10. So this 6x minus 10 is equivalent to this 2. So the value of x is obtained as 2. 6x minus 10 is equal to 2. So this is 12 upon 6x is equal to 12, x is equal to 2. At x is equal to 2, the value of y is on this curve. You place the value of x. So get the value of y as x. So the line, this is the point which from where the tangent line of the curve passing through. So this is the line 2, minus 16. So we place this value, and this is the equation of the curve, equation of tangent on the curve, which is also passing from, which is parallel to this line. So this was the required equation of tangent, line equation of tangent, which is tangent on this curve is parallel to this line. This have the required line have the same slope like this. We can see it here. So this is x. So the slope is same, so the lines are parallel. So let's move to seven, and now let's move to problem number 9. A curve has the equation y is equal to 4 plus x minus 1 power 4. The normal at the point 1, 4, the normal at the point 1, 4, and the normal at the point q 2, 5 intersect at the point R. These points, the normal at the point, at some point, a normal on this curve and the normal at this point intersect. They also intersect at point R. Find the coordinate of R. It's a very tricky, a little bit difficult. So we will draw this figure here and then we'll explain it. So this is the equation number 9. The curve is given as this: normal at point 1, comma 4, normal at point this, intersect at point R. Find coordinates of R. So we take the gradient of this curve, which is 4x minus 1 power 3. Now at this value, the gradient at point P, this gradient is 0. The equation of normal at point P is infinity. So this is infinity because the line is parallel to the y-axis. So at this point, this is infinity. So this is x minus 1. It comes in the denominator. This infinity will comes here at the denominator. So this becomes 0. When it comes in the denominator, this part is 0. X minus 1 is equal to 0. So the x is equal to 1 is the normal equation at point P. So at this point, the normal equation is x is equal to 1. So this is the normal equation at point P is x is equal to 1. Since the gradient at this point is 0, so the perpendicular would be infinity. So place it here and get this. And now the gradient at point Q. So the gradient at point Q is this 4, 2. So we'll place it 2, 5. So in this place we will place 2. This is placed here. So it gets 4. So this is 4. So the gradient at point Q, the perpendicular gradient for the normal equation, we have this here. So the equation of normal at point Q is equal to 5 minus 1 mq perpendicular x minus 1. So this is y minus 5 minus 1 over 4 x minus 2. So this is x minus. So this is the second equation. 1 minus 4. On simplification, we have obtained this, and this becomes this. So this is the normal equation at Q. At point P, the normal equation is equal to x is equal to 1. Here this is this. Intersecting 1 and 2 will provide the coordinates of R. So x is equal to 1 is placed here to get the value of y is equal to 21 over 4. The coordinates of R is therefore 1, 5 to 5, which is 21 upon 4. This is the required coordinates. So this is we can understand this is a difficult problem. This is let's solve problem number 12 or 13. 12, I think 12 is enough. 12. Solve problem number 12. Y is equal to x square divided by x plus 2. So we have this dy by dx, because this is u, this is v. So v u dash minus u v dash divided by v square. So this is so we solve it and we obtained it, and so this is the gradient, and at this we have x is equal to minus 3 is given. x is equal to minus 3. This given by x-ray. The equation of the curve is this: the tangent to the curve at the point where x is equal to minus 3 meets the y-axis at point M, and the normal to the curve at the point where x is equal to minus 3 meets the x-axis, meets the y-axis, and meets the x-axis at M. Find the area of the triangle M and O where O is the origin. So this is a very good problem, and so this is dy by dx at point x is equal to minus 3. We have this OM point because it is intersecting the y-axis where the value of x is equal to 0. So this is the gradient and OM, and from here we have the gradient value this, and similarly the perpendicular to this point is 1 over 3. This is minus 3. So the gradient, this is tangent gradient, and this is the slope on the normal. This slope of normal is 1 over 3. So the area of M and O is origin. O is origin. So at x is equal to minus 3, y, the value can be obtained. Minus 3, we can obtain the value of y, which is minus 3 and minus 9. Line OM can be obtained as this is M, y, this minus 3 and minus 9 can be placed here. So this is y plus 9 is equal to minus 3, x plus 3, y plus 9 is equal to minus 3x minus 9. This is y is equal to, at x is equal to 0, the y is 18 as per this. So this equation, the value is this. So the point M is obtained at 0 minus 18. On line ON, which is perpendicular, so this is x minus 9 and this is x plus 3 equals this. So this is y is equal to 1 upon 3x. So at this value, the value of y is 0. So crossing the x-axis, so the value at x-axis, the value of y is equal to 0. So we'll place 0 here. The x is obtained as 20. So we have M 0, 18 and 24 0 and origin as 0, 0. So the area of a triangle M and O can be written down as this: 0 minus 18, 24 0, and then 0 0, and then repeat this, and we will multiply like this. So this will multiply with this one with the minus, because this way multiply, we will get 0. On the other side we will get this. So this is minus half. So this is minus 18 and 24. With this minus, this becomes 216 units. So this is the area of this triangle, which is obtained as a result of this. Similarly for this problem 13, you can obtain these things very easily. So in the next session we will cover 12.6.